Today we will study about physics, CIE, particle physics, particle physics. First, we have the Rutherford's experiment. Basically, first, for some background knowledge, the idea of the atom was invented 2000 years ago. Was thought of by Greek scientists such as Plato and the other many other scientists, but that is not in our syllabus, so I will not discuss it further. Okay, now we'll discuss about the plum pudding model. Basically, a pudding like this existed. Basically, this thought. Let's say this is a pudding, and there the entire pudding's covering this yellow thing is basically positive charge, while the other parts are like the. I will also draw something else. Let's just draw it, make it larger, so we can do it quicker. Let's use this. So basically, people thought this was the plum pudding model. Plum pudding. Tiny negative charges in a ball of positive charges. Positive charges. So now we have discussed this. Let's move on here. Let's take this idea here, and basically next we have Rutherford's no, actually, who was it? Rutherford's gold foil experiment. Rutherford's gold foil experiment. Let's make it a bit more thin to represent it properly. Let's use another tool. Gold foil. So basically a thin gold foil was used. Basically alpha particles, type of, we'll discuss later what actually are alpha particles. So let's just assume these hit this. So basically some when passed through, this means the atom is very small, like this. Some were deflected at large angles, like this, like let's say it was reflected like this. Some were deflected at short angles, and some just passed through like this and this. So this made that the atom is basically very dense, has positive charge. But there was another idea. If some of them are deflected at small angles, so the nucleus has to be very dense, but the mass of the entire nucleus was not only could not only be made out of proton, but also another neutral charge particle called neutron, and their electrons were already there, so they were thought to be of spheres around the nucleus, as most of them passed through without any deflection or anything. So it meant most of the atom was actually empty space. So using this, we came upon a model called the nuclear model of the atom, gold foil experiment. So we used this to come up with this model. We come up with this model. Let me just let's just say, so this is basically where electrons exist, and these are nucleus, These red are proton, and the blue are neutrons. So it was like this. So we came up with this model after the Goldfoil experiment. Basically, let's talk about what these alpha particles were. Basically, these alpha particles were uh, high energy proton and high energy proton and neutron released because of instability. This relates back to isotopes instability. Isotopes. So basically we have this isotopes. Let's just discuss it. Two proton, basically in alpha there is two proton released. This is also related to the idea of chemistry, like some of the electrons, some of the will try, some particles will try to become more stable by reducing their electrons, but here protons and neutrons are released, so they are different as they are not chemical reactions, rather the release of hadrons due to release of like stuff. I cannot explain it properly, due to like due to instability. These are released alpha. Next, we after alpha we have beta radiation. After alpha we have beta. There is beta positive plus and beta negative. Beta positive and beta negative. Beta positive and beta negative. So beta positive basically a neutron turns into proton, so atomic number is reduced, so nuclear number is basically the let's say we have uranium 34. I don't know what the actual is its number, but let's say it's u 96. So proton number, this would decrease and this would station, so nuclear number stays same while proton number increases. Neutron turn into proton, so nucleon stays while proton number increases. So nucleon stays while proton number increases. So basically neutron turn into protons, so nucleon number stays while proton number increases. Stays same. It may be reduced, but I'm not sure. Let's say I'm just a student myself that was very bad at studying, but I wanted to improve. So here I am teaching others as a way of studying myself. I may improve on these videos further later on. Protons and nucleon stays while same proton stays same while proton number increases. Beta. There is also a release of a positron, which is basically an antiparticle, which we will discuss later. Antiparticle, which is basically a type of electron with positive charge. Positive charge electron with positive charge. Proton number increases. Positron, antiparticle, electron with positive charge. We also have a neutrino, which I do not know much about. So let's say neutrino. Here, proton turn to neutron, and it also an high energy electron is released as a beta minus particle, as a beta negative particle. High energy electron is released as beta negative particle. High energy electron is released as beta negative particle. Okay. And antineutrino, and antineutrino is also released. The difference between, we can differentiate beta positive by, the release of positron, which is an antiparticle but electron with opposite charge, and a normal electron with, high velocity, which of course is interesting to know, like an antineutrino. Okay, this is done. Let's say next we have gamma radiations. Gamma radiations are basically electromagnetic radiations, which are basically high energy photons that have radioactive properties. Electromagnetic radiation. Photons. It has no particles, but it does release a lot of radiation. So let's say beta. Basically, alpha can be stored. The differences between the penetration, that this can be stopped by a paper 5 millimeter thick, which is basically thin paper sheet, which is means that it's very weak, and it's just a chump. So let's talk about beta. It is basically stored by a 5 millimeter thick aluminium sheet. Gamma is basically stored by a lead, a very thick, so it's very strong, very strong and potent radiation, it's very strong, hence thick lead wall is required. So next we have, covering all of this about here, we have fundamental particles. Fundamental particles. Fundamental particles. The spelling is wrong. I'm an idiot. I used to have good English, but I'm now a dumb idiot. Sorry for that. Quarks, which are leptons. Nucleon particles, which are hadrons. Basically, quarks are even further smaller particles that maybe that are similar to electrons but different as they make up proton and neutron. Proton is made up of proton or hadron. Let's know proton, two up quark. This is a quark. This down quark. Neutron, down and up quark. Also, there's also fundamental forces, strong nuclear forces which affect fundamental particles such as quarks and electrons. Strong nuclear forces and strong nuclear forces, weak nuclear forces. These have a range of 10 minus 18 meter. This is 10 minus 15 meter. Then there's gravity and radiation, which are infinite. Gravity and radiation. Oh no, not electromagnetic. Electromagnetic attraction. 10 minus 10 meter, and this is infinite. So I'm done with here. Bye guys. This is all I know. So I will make another video for